All right, this is going to be a recap of what we did last night. As a few of you were unable to make it, I'm going to go through this really fast because I have a conference call in like 40 minutes, so I have to get through this in less than that. I'm going to log into Blackboard. And what we're going to do is we're going to cover mechanism. So we talked a little bit about state machines last time. And then we saw a 2D state machine. So this time we're going to do a 3D state machine. So go into Lectures and Labs. Go down towards the bottom. And there's a link there for Mechanim. And then you want to download this mechanim.toot.zip file. And then everything I'm going to do is in this video here. I just do it a little bit differently because version 5 has some changes in it. So I'm just going to cover really the first part of what we did so that you can see what the changes are. And again, I'm going to go through it quickly because I know you can pause the video and watch it over again. So if it seems like I'm going fast, I'm kind of doing that on purpose. I recommend that you watch this because it's going to have a lot more detail in it than what I'm going to go through. There are a lot of things in here that, since we're in a programming class, I care less about. I don't care as much about the rigging stuff or as much about some of the motion curve stuff. That's something that you should learn in your animation classes or in your rigging classes. But still, it's worth knowing, so I think you should spend some time and watch this video because there's a lot in it. Okay, so with this downloaded, it is on my desktop, and I'm going to extract it. And now I will open it. And it's going to tell me I need to upgrade. That's fine. And it should give me yet another message after that telling me I need to update my APIs. I'll say, yes, I made a backup, go ahead. And it will go ahead and update that. That might take a few minutes, depending on how fast your computer is. And once that process is complete, we can start working on it. So you're going to see a lot of these messages in here. There are some things in here that don't work the same way as they did in version 4, which is what this was created with, which is why we had to go through that long import process. This isn't right. So let's take a look at what we have. I'm going to go into my project tab, and you'll find in there a folder called finished. So if you want to see what the final thing looks like, now it's not going to completely work again because of the errors that we're seeing over here on the console. There are a few things that aren't going to work right, but you can at least see what it's going to look like when it's finished. If you go into scenes and then double click tutorial done, then you'll see the whole thing. And essentially what we've got is this robot that will run around. And we've got a camera that follows. You can jump. And normally he can bash through these boxes. These boxes aren't supposed to fall down the way they are. I suspect that there are differences in the way the physics engine works in 5 that makes them do this because they didn't used to be this susceptible to falling over. If you really wanted to fix that, then you could just add more mass to these boxes. But that isn't really the point of the exercise. The point of the exercise is learning how to code up our moving character here, and this time do it in 3D instead of 2D. So let's go down to tutorial and click the tutorial start scene, and that will give us our starting point. So we have all of our environment set up, but we don't have anything regarding our robot set up. So what I'll do is I'll find the robot right here, the prefab, and it's already been imported for you. So this is an FBX, which is an animation format, and that's the only one that you can import that actually will allow you to bring in animations. Now that said, what's interesting about this is this one doesn't actually have any animations on it. So with robot selected, I can come up here to animations and I can see that there are in fact no animations here. If there were, then the clips that we were importing would show up here. So it's just geometry. And what's interesting about Mecanum is that you can take animation clips from other models that were modeled with other rigs and use them on different models, as long as the rigs conform to what Unity expects in its humanoid rig factor. So let's go look at that. So if I click on rig, right now it doesn't have one. You can see a preview of your robot down here, but there's no animation type set for him. So that's the first thing we need to fix. So let's change this to humanoid, and I'll click apply. And then I'm going to click configure. There's nothing we need to do in configure, but I want to show you what it is and how this is working. So when I click configure, I'm going to see the bones for the rig on this animation. So while it didn't have any animation clips, it was properly rigged. And by properly, I mean they followed the specifications that Unity expects for humanoid rigs. And you can kind of see a map over here of what that entails. So all of these circles, these are required joints. So when you're rigging your character as a 3D modeler, you need to basically rig it with these joints, and they need to be named in such a way that Unity will be able to find it. So if you call it left shoulder joint 01, and you basically follow this guideline, then everything should work for you when you pull it into Unity, and you can reuse your animation motions from rig to rig. The ones that are dashed circles, these are optional, so you don't have to have those in there, but it does recognize them and you can use them if they are there. So one of the differences in Unity 5 is that you no longer have to enforce a T-pose. And I suspect this is because really they went in and fixed the robot, not because of any change that they made to Unity. But in the Unity tutorial video, there is a section where you're supposed to go in and click Enforce T-pose because some of the joints are red, and you don't have to do that anymore. So either they fixed the robot or they fixed Unity. But if you need that, it's right here. So if your model were not in a T-pose, you could force it into a T-pose by selecting Enforce T-pose. And that will help Unity recognize the maps more readily if it's not recognized them automatically as it's done here. And we can see that it's recognized everything because this is all green. If you had any areas that were red, that would tell you that you would have some work to do down here with respect to mapping them up. So this is really something you should learn about in your rigging class, but I did want to make you aware of that and where it is and what it does and how all this works. I'm going to click Done. And now I've got my robot. I'm going to put my robot in my scene. And I'm just going to roll back and find the camera. I can see the camera's right there. So I'm just going to drag and drop my robot over there near the camera, because right now our camera doesn't have any script on it, so it's not going to do anything. But I do want my robot to be in the camera shot so that I can see him. So I will manipulate this until I have a view of my robot in the game window, and there he is. Maybe pull him over a little more. Okay, that's fine. And now the next thing I'm going to need is an animation controller. Now there's already one here. There's one called Robot 2, but I want to show you how to make it from scratch. So let's right-click inside the Assets window, click Create, and then find Animator Controller. And let's call this My Bot Controller. Now throughout this tutorial, I'm going to have you create things with particular names because the script is expecting particular names. So I'll tell you, you have to create something with a particular name. You need to make it exactly with that name, spelled correctly, paying attention to uppercase and lowercase letters and make sure it matches. Otherwise, things are not going to work correctly. All right, so we've got our bot controller, and now we just need to attach that to our robot. So robot is here. I recommend that you move this up to the top. There are really two things that we're going to be working with, and as of, I think, Unity 4.6, you can reorder your hierarchy however you want. In older versions, it was always alphabetical, and that wasn't always helpful. But now I can click main camera, and I can drag this and drop it up here. And the two things that I'm going to be working with in this tutorial are going to be the robot and the camera. So with those at the top, that's going to make things go just a little bit faster. So now I've got the main camera here, and actually what I want is the robot. So I'll select the robot. We've got a place here for our animator controller. So I'm going to take the animator controller we just made, the MyBot controller. I'm going to drag it and drop it right here. So I'll do that. And now that's in place. And if I double click it, it's going to open up the animator window. So we worked with this last week. We made a nice two-dimensional animation from some state machines. And we're going to do the same thing this time, but it's going to be a lot more complicated than what we made the last time. Starting off, we're going to make something really simple. So before we get started, I'll just mention that there are these three boxes that you get in here by default. The starting point of the state machine, the exit point of the state machine, and then this any state. I don't really use these very often. You're kind of stuck with the entry point because it automatically connects to whatever you put in there first. So those are just kind of there, and you don't really need to worry about them. If you hold down your center mouse wheel, if you click with your center mouse wheel, you can move this around, and that comes in handy because eventually this is going to get a little bit crowded and you're going to want to move things around. So for starters, let's go into our animations. They're all within this animations folder here, and they're organized a bit oddly, but the first one that I want to find is the idle animation. So find this prefab folder here that says idles, open it up, and you've got all this geometry here, which you can ignore. Scroll all the way down to the bottom, and you'll find something that says idle, and it looks like it's got a little play button next to it. So let's click that. That is the actual animation clip. So I can click on that, and I'll see a preview over here. You'll notice that it's not our robot, and this is what I was telling you earlier. This is actually modeled onto a different character, but the character has the same rig as our robot, so we can reuse the animation clips that are on this animation with our robot, and that's really cool because we might want to reuse a lot of our animation motions. So this is our idle sequence, and you can see he's just sort of swaying back and forth. An animator might call this a moving hold. This is where he's just standing there, but nothing is ever really still, so he's just sort of swaying back and forth. So let's apply this to our robot first. I'm just going to drag this and drop it out here, and it's going to automatically create a state for me, and it's going to automatically create a motion field right here, and it's going to automatically put idle in there. So I got all of that by dragging and dropping. Very easy. I could have just as easily, or maybe less easily, right-clicked, selected Create State, and then Empty, and then selected this, and now I have a motion field. I could have also dragged and dropped this idle in here, and it would have been the same thing as what I did, which was to drag it and drop it out here. Now you'll note that idle is orange. That's because it was the first state that was created, and the orange state indicates that that is the default state, which is exactly what we want in this case. We want them to default to idle. I'm going to get rid of this. I just created that to show you the long way of making it, so I'll get rid of it. And now I can actually go and run my game and see my robot has implemented the idle state. So he's doing exactly what our character did earlier in the preview mode. He's just sort of swaying back and forth over there. We don't have any sort of scripting involved here, so if we press the buttons that would cause him to otherwise cause him to run or walk, as we saw in the earlier demonstration, none of that's implemented yet, so nothing's going to happen. We actually have a little bit of work to do before any of that can happen. So why don't we switch back over to our scene view and get some of that preliminary work done. The first thing I'm going to want to do is I'm going to implement the workflow where he walks, or I guess I should say the state machine where he walks backwards. So the idea is you ought to be able to press the arrow keys on your keyboard. The up key will cause him to move forwards. The down key will cause him to walk backwards. Left and right will cause him to turn respectively while he's moving. So we don't really have anything where he's going to turn while he's idle. When he's idle, he's just going to be standing there. So let's go back into our animator window and let's build our walk back state machine. So for this one, I'll right click, I'll click create state, and this time instead of clicking create empty, I'm going to create from new blend tree. So a blend tree, if you've ever worked with Flash, I like to point this out because a lot of people in our programs have. This works a little bit like a symbol insofar as the way that you work with it. I'm not saying it's a symbol the way it's a symbol in Flash. I'm saying that when I double click this, I'm going to get a little breadcrumb up here at the top, just like you would in Flash when you double click a symbol to edit it. So when I double click my blend tree, you'll find that it has this base layer first, and then the blend tree that I just double clicked, and now I'm inside the blend tree. And when I click the base layer again, I'll go back out to the base layer where everything else is. So these are sort of layers unto themselves. So I'm going to double click the blend tree, and I'm going to add 3 motion fields to it. So this is one of the things that's different about a blend tree. A simple state has 1 motion field, a blend tree has multiple motion fields. And what you'll see is that it's actually going to blend your animations together as the states change. So I'm going to click the little plus sign here, and I'm going to select Add Motion Field. And I'm going to do that 3 times. And it's going to create 3 motion fields for me. This is the first part that is different from what's in the Unity 4 tutorial that Unity has. The first thing you need to do to fix this is this Automate Thresholds checkbox is automatically checked. It didn't used to be. Usually it's not checked. So let's turn this off, because what we want is a threshold that isn't 0 to 1. So we've worked with Unity quite a bit over the semester, and we made the marble game that is part of the Unity tutorials. And we learned during that phase that when you're interacting with the keyboard, it's a range between -1 and 1. So if I hold the up arrow down on my keyboard, I'm going to get a value of 1. If I hold the down arrow down on my keyboard, I'm going to get a value of -1. And if nothing is pressed, then I'm going to get a value of 0. So we do all that with the get axis commands, and we've seen those before. Likewise with left and right buttons, if I hold down the left button, I'm going to get a -1. The right button, I'm going to get a +1. And if I don't hold anything down at all, I'm going to get 0 on the x-axis for my axis values. So with that in mind, I need to change my threshold from -1 and then in the middle it should be 0 because that's the idle state, and then we can leave the last one at 1. Just the way it is fine. So I'm going to now go ahead and find my 3 animations that allow me to walk backwards. They're right here. You'll see walk back and turn. So let's do walk back first. So I'll scroll down to the bottom again. I'll find walk back. I'll drag and drop that into the center motion field. And you'll see it appear here in the diagram. It's all nice and wired up for us. And now let's find walk back and turn. Let me open that one up. And I'll put the left one on top and the right one on the bottom. And we are almost finished with this. I think I can preview it. So there he is walking backwards. Now all I need is a parameter. So we covered this last time. And you just need to find the parameters tab. Mine is right here. So parameters are a way of putting, basically they're just putting variables into the state machine, and then your scripts can manipulate those variables. And as those variables change, they're going to be tied to different clips here in Mecanum, and that's how we're going to affect all of our changes with respect to our animations. So we're going to add 2 parameters in here. They're both going to be floats, and we'll talk about what all of these do during the course of our tutorial. But by and large, you're almost always going to be using floats or triggers and potentially every now and then bools. You don't use integers all that often, just in my experience. I'm going to select 2 floats, and this is important. You have to call them exactly what I call them. I'm going to call them direction with a capital D, and I'm going to call the second one speed with a capital S. And make sure you spell these correctly because we are going to be accessing these from a script. And so it's important that the names match. So direction and speed. So direction is going to correspond to what we get off of the axis on your left and right buttons on your keyboard. So left is going to have a value again of -1 and all the way to the right, +1. Direct, and that's direction. Speed is going to be the up and down arrow. So if the up arrow is held down, we're going to have a speed of 1. If the down arrow is held down, we're going to have a speed of -1. And this is what's going to cause our blend tree to work. So the last step, and there's actually a message down here at the bottom telling us that we have a problem. It says that our default parameter is blend, and you really can't do that. You can use that for previewing, which we have, for preview works, but that's not something you should use in production. So this is set to blend. That's a no-no. We need to change this. And we're going to set this to direction. So that's what this whole thing is going to do. It's going to change the direction that our robot is traveling. So now when I click this and I'll see this direction field, I can simulate what will happen when I click the buttons on my keyboard. If I move this all the way to the left, they'll turn in one direction. If I move it all the way to the right, they'll begin walking in the other direction. And what's really going on here is we've got 3 different animation clips working together, and that's what these blue areas here. So this is showing you the motion curve between these 3 animations and how they're being blended together as the state changes. So this is why we can have 3 motion fields and they're being blended together, and of course that's why we call it a blend tree. Alright, I'll stop my preview and I'll go back to my base layer, and I'm going to click on this and name it something other than blend tree. This name isn't all that important. I'm just going to call this walk back. And now I just need to create some transitions between idle and walk back. And I'm going to set my transition between idle and walk back first. So I'm going to click this one. This is another change from Unity 4 to 5. Make sure you deselect this has exit time checkbox. If you don't, it's not going to work correctly. I'll show you an example of what happens if you leave that checked later so you can recognize what happens. But for now, let's uncheck it. We're going to set our condition just like we did last time, and this time it's going to be speed. So if our speed goes negative, so by default in idle he's 0. If it goes negative, then he's going to walk backwards. So I'm going to set this to less than -0.1. So as soon as that value goes negative, then we're going to start walking backwards. Likewise, if I come out of this state, that's going to happen when speed is greater than -0.1. So that's what's going to transition our robot back into the idle state. Now would be a good time to save my scene. I don't think I've done that in a while. And let's go back to our scene view. There are a few things that we need to do before we can make our robot actually walk.
So the first thing I'm going to want to do is go back into the hierarchy and select the robot. So let's do that. And now there are some things that we need to do here. So here's the good news for this exercise. You don't have to actually write a script. We're going to use one that's already supplied. So I'm going to select Add Component, and I'm going to go to Scripts, and then select Bot Control Script. So this was already written for us, and that's super nice. It allows us to focus on making our state machines correctly. And I'll show you all the different things that it did, because you'll notice that when you added the bot control script, you got more than just the bot control script. You got a rigid body and a capsule collider. So let's open this up in our code editor to see what we've got.
I'm going to have to make this not full screen. Okay, there we go. All right, so the first thing I want to point out are these decorators here. Anytime you see something with the curly brackets around it and it's above a class definition, we call that a decorator. So this is going to add extra behaviors and functionality into our class just by adding these on here. And this one is unique to Unity. So require component is basically what gave us those components that we didn't add. So we had an animator already, but we didn't have a rigid body, nor did we have a capsule collider. So this require component statement adds that on, and if it's not there, then it just creates it with our defaults in place. There are a lot of other things going on in this script as well, so let's take a look at the high points. We don't really need to cover everything in the script, but we're going to cover the parts at least that we should be familiar with. So let's scroll down and let's find our start method, and we can see that we have a reference to our animator component, a reference to our collider, and there's a reference to the enemy. We don't really need that, but those two we do need, so especially the animation controller or the animator. And then here is something that should be very familiar. So we've done this before. We're getting the axis. This is what allows us to get the input from the keyboard, or if you had one attached, you could use a joystick or a game controller. Without doing anything extra, it would just work. So here's where we're getting the values that we're plugging into our state machine, the horizontal and vertical. Vertical would be the forward and back buttons. Horizontal would be the left and right buttons. And that again has the range between -1 and 1. And so that's where that's coming from. And then I told you that we had to be very specific about how we named our variables in our state machine, and this is why. We did this when we did our 2D state machine, and you created all of your own variables from scratch, but this time we're using someone else's script. And so it's very important, because when we call into Mecanum, we're calling it with strings. So we need to match the name of the string to what appears in the parameters window. Speed and direction here, those need to match speed and direction here, otherwise it's not going to work. So those are the most important parts for now. If you look through the rest of this, there are some other things in here that we don't really go into, but you can watch the full video on the Unity site and see the whole thing and how all of it fits together if you're interested in going all the way to the end and seeing lots of different techniques within Mecanum. But we are going to do the jump. So we'll come back to that when it's time. So let's switch back over. Now that we've added our script, we need to do a little bit more work on our robot. So I'm going to switch back over to my scene again. And with my robot selected, I need to change our capsule collider, because right now it's at his feet. So if we ran this, he would actually fall through the ground, and that's obviously not what we want. So let's change the radius to 0.3, the height to 2, and let's set the center in Y to 1. And that should bring it up around the robot. And of course, if you really wanted to fiddle with it, you could spend a lot of time doing that. But I'm not going to, so I'm just going to take those values and hopefully get him down enough, close enough to the ground where hopefully he's not going to fall through. Let me just check real quick. Okay, that's good. So he didn't paratrooper, nor did he fall through the floor, so that's pretty good. And the boxes are falling over because they just don't have enough mass. It seems like it was a lot less prone to that in the last version. All right, so that's our capsule collider. We're set up. We're good to go here. But if we run this, it's going to look really bad. So let me just show you. The only thing that's wired up is the back arrow. So if I hit the back arrow and he falls down and just sort of kicks around a lot, he doesn't actually go anywhere. The reason for this is because there's a rigid body on him, and as soon as we apply force to make him move, he's actually rotating, and the rotation is causing him to trip. So what we want to do to fix that, there's two ways to fix it. There's the quick fix, which is to simply select is kinematic. That's not what I'm going to do, but what that does is it says, hey, physics engine, I'm going to relegate all control to the scripts. And so you shouldn't do anything with respect to the movement. I don't necessarily want that. All I really want to do is prevent him from rotating according to physics. So let's just turn off rotation by selecting freeze rotation here in constraints. And I'll use all three axes. And this time when I run, or walk I guess I should say, it works fine. And if I hold down my left arrow while hitting the back button, he should be walking in a circle that direction. And then the other way seems to be working well. The only thing I'm noticing is when I let up on the keys, it seems like he doesn't stop walking right away, so I'll check that. That more than likely is me forgetting to click one of these checkboxes with the exit time on it. Yes, and that's what I've done here. So when you have your transitions, make sure that you turn off this has exit time. And if you don't, what will happen is it will play the entire animation before moving into the transition, which is going to make this appear laggy and as though it isn't working correctly. Let's try it now. So there he is walking that way, and now I'll walk him the other way, and I let go and he should stop right away. Ooh, he seems to be floating though. Hopefully that was an anomaly. Alright, so that's the basic setup. Let's go put together the forward animation, since that's going to be a bit more complicated. So as before, I'm going to create a blend tree, and I'm going to call this one locomotion. And this is one of those things where you want to be careful with what you call it because it's called from the script. So we'll call this locomotion. I had selected the wrong thing. There we go. And now let's go inside of this by double-clicking it. And as before, we're going to add some animation clips into our blend tree, but this time, instead of doing it with 3 sets of motion fields, we're actually going to make 2 more blend trees. One for running and one for walking. And so let's add 2 blend trees, and then the first blend tree is going to be the walking. So as before, I'm going to add 3 motion fields. Turn off automate thresholds, change the thresholds from -1 and 0 and 1, like so. And now I just need to find my animations. So let me find those. And in this case, we're looking for walk forward. And here they are again, so they're split up. So walk forward is going to be at the bottom. So let's drag that into the center. And now let's do walk forward turns. We'll put left on top and right beneath it. And now we just need to change our parameter. Actually, it's at direction, which is what we want, so that's fine. And then we need to do the same thing for the other one. Let's go ahead and label this walk so that we can remember which one is which. And then we'll do the same thing on this one. We'll add 3 motion fields, turn off the thresholds, set them to -1, 0, and 1 respectively, and make sure the parameter is set to direction. And then from here, just find the animations that correspond with running. And in this case, they're all under run. So if you go down to the bottom, you should see all 3 of them there. Run goes in the middle, run left at the top, and run right at the bottom. We're all set. I'll save my scene. I'll go back to my blend tree, and this one is going to be speed rather than direction, because that's going to determine which one goes, running or walking. And I guess I should rename this one as well to run. Again, just so we can tell which one is which. And I'll go back out to locomotion. I think I renamed my controller is what wound up happening, because I see that there now. But that's okay, I won't hunt it down. It shouldn't matter. Okay, now I just need my transitions. And this one is going to work in a similar fashion to the last one, but with a different value. So I'm going to add speed, and I'm going to say greater than 0.1. So as soon as that value starts to go positive, we're going to transition into the walking state. And then if it gets above a certain threshold, then it's going to as it approaches 1, it's going to move into the running state. And that was the whole point of the blend tree. The second, we'll transition back in. We'll make sure it's set to speed. And this one's going to be less than 0.1. And make sure you turn off the has exit time on both of them. So just a quick check, speed, as it gets bigger, will go into locomotion. As it gets smaller, it will come out of locomotion. I've deselected all of my checkboxes. Let me just see if this works. So he should run forward, walk backwards. He should be able to run around in circles one way, and then run around in circles the other way. And it looks like he's a little skewed there. Okay, after fiddling around with this a little bit, I've discovered my problem, and I could have sworn that I typed these incorrectly, but I guess they didn't take. So in the middle of my 2 states here, these 2 blend trees, my transition, or my threshold rather, in the middle is set to 0.5, which was what it defaulted to, and I really wanted it to be 0 in both cases. In Unity, you have to be careful. Anytime you see a blue box like that, you really need to press enter just to make sure that it takes, and you can see the visual difference between the 2. Earlier, I was hitting the tab key, and sometimes if you hit tab, the change that you made doesn't actually take. So be sure to press enter, and you'll avoid these sorts of problems. So I'll save this, and let's try it again. And now it looks like he's running correctly. So the last thing that we need to do is set up our camera follow script. So for that, you just need to find the camera in the hierarchy, and we're going to add an existing script. in this case, third-person camera, and I'll show you what it does. This is like a really, really simple camera follow script. And all it really does is it looks for an object called comprise, and it gets its transform, and then from there it just makes sure that the camera is always looking at that particular object. And then we've got some nice math going on down here with respect to moving the camera smoothly. And so that's what this lerp does. The lerp actually changes the position of the camera. And it does that based on time.delta time, and that basically allows us to have smooth movement of the camera regardless of your frame rate. And then we've got a nice little smoothing factor in here as well that we can set in the editor. And then this part up here, if you're using the fire function, which we haven't built, but if you pursue that avenue of development in the exercise, then you can actually have the camera look at the object that the robot's firing at instead of looking essentially forward over the shoulder of the robot itself. So really simple follow script, only a few lines of code. This is the kind of thing that you could probably reuse in lots of different places. Okay, so let's go back over into Unity, and there's just one more thing that we need to do. We've got the script on our camera. We need to add this comprise object to the robot. So let's select robot, and let's find comprise. It's in the prefabs folder, and it's right there at the top. And when you drag this over, you want to drop it on your robot, but you want to make sure that you drop it on the geometry, which is robot 2, and just make sure that you drop it underneath robot 2, and I missed, so let me do it again. That's what you want. You want it to be on the geometry like that so that it's parented beneath the geometry. If you go under robot 1, you're going to get unpredictable results because really that's the whole package. When I select robot, I'm going to get everything, including the collider, the rigid body, all of that. And this is really positionally dependent. It's going to be positioned based on where it is on the robot. And so in order for it to look right, then you need it to be on robot 2, which is the geometry. So if that all worked correctly, I should be able to click the run button. And now I should have a camera that moves into position, and now it should follow our robot as we run around. And we should be able to go backwards in either direction and forward in either direction. And if you happen to have a gamepad, then you can attach it and actually get the walk animation. That's the only way to do that would be with a gamepad, because that's the only way to get a fractional speed moving forward. And that is essentially it. So for the rest of the tutorial, you can just follow along the Unity tutorial link that I posted. And that would be my 3-year-old. Wishing you all the best. Say goodbye, Phoebe.
Goodbye.
All right. Thanks, guys.